Hi, my name is Kriti Dogra and I'm a solutions engineer at Snyk. Today I will be talking to you about advanced CI/CD configuration options using the Snyk CLI and some plugins that we can use to achieve some interesting use cases. In this talk, you will see that making these set of changes is relatively straightforward. They're also very flexible and can be used for a wide variety of other use cases that might be different than the ones that I'm discussing here. To set an agenda, first we can start with why it's so important to have security embedded into our CI/CD pipelines and discuss the problems that we're trying to solve. We will then move on to discuss the different maturity stages with respect to security to have a successful implementation with minimal impact. For each stage, we will see this Snyk CLI in AWS code build in action. The later security issues are found in the software development lifecycle, the higher is the cost to action on them. Essentially, code has already been landed or deployed, and usually the developer would have moved on to work on the next feature or problem. We can use the Snyk CLI in the CI/CD tools to automate security checks with the pipeline to give you early warning and monitor escaped security vulnerabilities. However, every organization or even different teams within the same organization might have different compliance and regulatory obligations. While one team might be working on a payments-focused product, another team might be focused on an open source dependency injection framework. Different teams might be in different stages of their capability maturity model. A team with a more mature product might have to uphold more stringent security policies than a team which is, say, incubating a new initiative. Moreover, work cultures can also differ a lot in different teams. Whereas one team might have some security tools and initiatives in place, have a designated security champion, other teams might not have given security as much of a forefront priority. Because of this heterogeneity, it is imperative that a security product is flexible enough to adapt and cater to the aforementioned nuances. This timeline outlines the journey of an organization in its implementation of security in their pipelines. For each of these stages, we will discuss a few use cases and I can show you how we can use the Snyk CLI to achieve them. When an organization is just starting off in their journey, there's a couple things to be mindful of. There needs to be a balance between fixing issues and overwhelming the engineering teams. It is impossible to have the strictest policies set in place without adversely impacting the agility of engineering teams to ship products and features. The first step in their journey would be to understand the security exposure as it exists today. Understanding how many high, medium, and low vulnerabilities they have, creating a baseline to work off of. We can achieve this by using the Snyk monitor command. Before we implement this in our pipeline, let's see how we can achieve this on our local. I've authenticated the CLI using Snyk token, and now I'm going to run a Snyk monitor command on here. After this runs, we can get a project in our Snyk UI. We can click into it and get a better understanding of all of the vulnerabilities. However, the Snyk monitor command takes the first manifest that it finds and posts the results. If we have a mono repo, a single repository that has all of our code and assets, then we might need to take a different approach. For this, we will be using the -- all projects in conjunction with the -- detection depth command. This command will traverse through each of the folders till our desired depth to look for manifest files. And once they find them, we will create projects for them. So after running this command, we can see that I can see all three of the manifests within my Snyk UI. Now let's try and implement this in code build. Before this step, I did store my Snyk token in the parameter store in AWS Systems Manager. I can then add a Snyk monitor command in my build spec file as a post-install step. I also added a project name here to easily identify this build. Just like it worked on my local machine, this will take a snapshot of the dependencies that are installed in this application and then query them with a vulnerability database and post the results on Snyk.io. Let's start this build and see the results being posted. So the build is complete. We didn't block it at this time, but instead posted the results here on Snyk. They can give engineering and security leaders a gauge of the overall security posture, a holistic view into the vulnerabilities that exists, and going forward, understanding the trends. We can also go to the Reports tab and get aggregated views about the vulnerabilities and dependencies. Next comes our beginner stage. At this time, maybe management and security champions have visibility into the vulnerabilities that exist, but we would want to spread this knowledge among everyone. At this time, it might be important to do so in a non-intrusive, a non-obstructive way. It needs to be information that will give engineers insights into the vulnerabilities. Maybe they will look at it, maybe they will fix some of the low-hanging fruit, but most importantly, they will understand what the security of their application looks like. We can essentially use a tool that the entire organization uses. If I were to implement this with our team, it would be Slack because we're always on Slack. Now we're back in our build spec file, and that's the source for our pipelines. Here I will use the JSON command to generate a JSON output and pipe it to the Snyk to HTML package. This will generate a report that can be sent to people across the organization. I will convert it to a PDF, and then by creating a Slack bot and using the Slack API to post it to my desired channel. Now let's run the build and see this in action. So what happened here is that our pipeline ran, and if I move to my Slack browser, I can see that this report got generated from my last build. I can click into it and get details about the vulnerabilities and fixes. Maybe I can even add some emojis or tag some other teammates to get more visibility into this. At the next step, we're actually going to start enforcing some policies. However, we want to be cautious about doing so because we don't want to overwhelm the development teams with noise. At the same time, we would like them to take action based on the quality of code that they're introducing into their applications. At this time, we might just want to break builds on any new vulnerabilities that are being added. This would essentially mean scanning for vulnerabilities on any new code that has been introduced by a developer from the time of the last scan. This is the CI/CD equivalent of a Git pull request check. To achieve this step, we're going to use the Snyk Delta plugin built by the Snyk Tech Services team. This uses a baseline project and compares the vulnerabilities in the current scan. If no vulnerabilities have been introduced from the last build, we want to pass the build. However, if any new vulnerabilities have been introduced, we want to break this build and provide information to the developers to fix it. This would have a lot of value because the developer who just made the change can quickly go back, make some edits, make sure this is not introducing new vulnerabilities, and go forward with their deployment. It makes sure that developers learn about their vulnerabilities right after they've developed, so it's still fresh in their brain and making these changes is less expensive. At this point, we might need to have a little more aggressive approach. We can assume that through the visibility that we have given, some of the low-hanging fruit has been picked. A good example of that is when the developers understood about their vulnerabilities, they fixed the high-severity vulnerabilities with fixes available. But we would still have plenty of critical vulnerabilities that might need more legwork than a quick fix. Or maybe even some that don't have fixes available, but someone needs to look at it. At our advanced stage, we want to tactically trigger a workflow that is integrated with developers' workflow and is time-bound to get them to look at such critical issues. For this example, I used Jira to help me. The Jira ticket for new ones plugin uses the Jira API to check if the ticket for that vulnerability exists, and if it doesn't, creates one for the developers to see. I have also added an additional option of severity because I only want to create tickets for high severity issues to prevent noise to developers. For this purpose, I've created a new Jira board with no tickets. Let's run this pipeline and see what happens. All right, we can see that this pipeline passed with no issues. And if I jump to my Jira board, this is now populated with the tickets that I created from my pipeline. They have been pulled into the developer's backlog, and during sprint planning, these can get evaluated and have an expected date set on them. At the export level, it's time to have some strict policies in place. Creating policies might mean a lot of things to different organizations or even teams within organizations. For some organizations, they may just want to break their builds if they have high severity vulnerabilities. Some could be compliance heavy and want to fail on any licenses that goes against their license policy. Some policies are already inbuilt in Snyk. The test command on default exits with a non-zero exit code every time there's vulnerabilities in this application. This would essentially mean that the pipeline would fail in that case. We can have stronger control of these exit codes. Some of it can be found using the help flag. For example, you can set a severity threshold. So say if you set a severity threshold of medium, the task would only fail if there were vulnerabilities of severity medium or above. You also have an option of fail on. This means that you would only fail on issues when you actually had actionable fixes to act on. The JSON output can also be achieved using the --JSON flag. When I run Snyk test with the JSON output in my local, we can see that the JSON has a lot of important information that is valuable to engineering, security, and compliance leaders. For example, I can get CVEs, CWEs, attack vectors from this information. I will now use the JSON output to create a simple rule in code build. In this example, I used JQ to parse the JSON and fail on all critical vulnerabilities of CVSS score of 9 or above. However, in real life, the policies could get a lot more nuanced. For example, I might have an external facing application in which I want to break if there's any SQL injection vulnerabilities, even if it's a low severity one. At the export stage, security, engineering, and compliance teams can collectively build their policies according to the use cases to create security gates for their applications. There is a tool by the tech services team called Snyk Filter. In this tool, you can set your pass criteria and filters based on the JSON output, and it handles the failing of the pipeline accordingly. This plugin and a lot of other useful plugins can be found on the Tech Services Team GitHub account posted here. Additionally, all of the build spec files that I used in these examples are available on this GitHub. I hope you can incorporate some of these primitives that I covered in my examples today in your pipelines. Thank you for listening.